Okay. As x continually increases in value without bound, the value of x over x plus 3 most closely approaches. So this is just a limit question, and it's asking the limit as x approaches infinity. And if you take an algebra 2 or anything higher than that, pre-calculus, calculus, this should be pretty easy. But if not, it's still pretty simple to do. Just think, right? As x gets really high, say 1,000, right? Then the value of this function will be what? 1,000 over 1,000 plus 3, which is 1,003. And this is pretty close to 1, right? I mean, it's almost 1. So I mean, yeah, you just think this is the x over x, right? Is you talk about dominant terms, and so that's the term with the highest degree, and degrees are the powers of x. So like x to the n, and whichever n value is the highest is the one that dominates. So like here, this is x to the first, and in the denominator you have x to the first plus 3, and then there's an x to the 0th power. You just don't see it because it's equal to 1. So in both the numerator and the denominator, x and x to the first and x to the first dominate. So those are the ones you want to look at. And also it's good to remember coefficients. For example, if it was 3x over 3x plus 3, right? We know 3x would dominate. We know x would dominate, but there's a 3 in front of it, and we want to keep those coefficients in front of the dominating terms. So 3x over 3x, and that's still simplifies to 1. But if you had 3x over x, then the x's would cancel as they approach infinity, and it would actually be 3. But in this case, we just have an x over x plus 3, and as it increases without bounds, to say 1,000,000, it'd be 1,000,000 over 1,000,000 plus 3, and that's almost 1. So that's the answer, H.